Welcome to this episode of Robert's Creative Chronicles. So today we'll be solving this question. Find the position of the center of gravity of an unequal angle section, 10 cm by 16 cm by 2 cm. Solution. So before we proceed, we have to first draw this on the unequal angle section. So this is the unequal angle section, and the dimensions are 10 cm by 16 cm by 2 cm. So what this means is that here will be 10 cm, here is 16, and here is 2 cm. The first one is here, the second one is here, and the third one is here. That's the general way. So this one will be what, 10 centimeter. Then this one is what? 16 centimeter. Then this one is what? This one is 2 centimeter. This one is the same thing as this one. So this is height by width by thickness. So now let's go back to the question. Find the position of the center of gravity of this unequal angle section. Now in this one, since there is no plane that we can find symmetrical, like in T section, there's the y-axis is the axis of symmetry. So the center of gravity will lie on that y-axis. But in this one, there's no axis that we can find. We cannot even find one axis that is symmetrical. Because you see how where will we find? Is it here or here? So we have to use two axes as our reference axis in this one. Unlike the T section that we have to use only one, we only need to use only one axis in T section as our reference axis. In this one, we have to use two, because there's no one that is obviously symmetrical here in this unequal angle section. So this one will be our first shape. This is the first one, which is the first rectangle, and this is the second one, second rectangle. So now, the first step we are going to find the center of gravity of this, the first step we are going to do, we are going to use the method of moments here to find the center of gravity of this shape. So the first thing we have to do when finding this is we are going to locate the center of gravity of this first rectangle and also this second one. The center of gravity of this rectangle will be somewhere here. It will be half of 10, which is 5, and half of 2, which is 1. So it will be here at the center. We know that in a rectangle, the center of gravity is at the center. Also in this one, it will be here. So this is center of gravity of this one, and this is center of gravity of this second shape. So you find the center of gravity of the individual shapes. This is the first one, this is the second one. That is from here to here. And this is from here to here. So now the second step, we are going to use, in this one, as I said before, we are going to use two reference axes. It is more convenient to put the reference axis here and here. Normally, some people used to put it here. Anywhere you put it, you still get the same answer. But the answers you'll be getting along the way will vary. But the final answer will be correct. That is the center of gravity of this shape. So now, let's put the reference axis. So this will be my x axis, and this is my y axis. So now we are using method of moments to find the center of gravity. So now from the first rectangle, we will find the area of this rectangle. So I'll call it A1. A1 will be equals to, is the area of rectangle is length times breadth. So we'll just say 10 multiplied by the breadth here is 2. So it will be 10 times 2, which is 20 centimeters square. This is the first area. Since we are using two reference axes, we are going to find x1, y1, x2, y2. Now, we will find the distance from this centroid to this reference axis. We will find distance from this centroid to this reference axis. We will also find distance of this centroid to this reference axis. Likewise here and here. So now, this is the first rectangle. So this will be what? X1. The distance from the first centroid to the y-axis is what? Is x1. So this is the horizontal axis, so it's x1. Now, you know that here, from here to here, will be 2 divided by 1. It will, from here to here, since here is 2. So the distance from here to here is what? 2 divided by 2, which is 1. It to be 2 over 2, which is 1 centimeter. Then y1, this is y1 on the y-axis. The distance from this centroid to the other reference axis, which is what? This will be what? 10 divided by 2, which is 5. To be 10 divided by 2, which is 5 centimeter. Then the second rectangle. We'll find the area A2. A2 is what? Here is what? 16 minus 2, which is 14, times 2, which is 28 centimeters square. Then x1, x2, now will be x2. x2 is equal to what? That is here. x2 is the distance from this centroid to this reference axis. So it's what? From here to here is 14 over 2. Here, from here to here is what? Is 14. So it will be 14 over 2 plus 2. Here is 7 plus 2, which is what? 9 centimeter. Then y2 is what? Is here. The distance of this centroid to this reference axis, which is, this is on the y-axis, which is y2. So y2 is what? Half of 2. 2 over 2, which is 1 centimeter. So this is it. So you have to find all the reference. So you have to find the centroid of the individual shapes. Then you find their distances from the reference axis, which is x1, x2, y1, and y2. Then you find the areas of those shapes individually. Then now we will take moment about y-axis and we'll take moment about x-axis. This is called the moment of area, not your normal force times distance moment. This is area times distance moment. So now, when we take moment about y-axis, what are we going to get? It will be, when we take moment about this y-axis, it will be these areas times, it will be these areas, there's A2, there's A1. It will be these areas times the distance from this y-axis, like we do in normal force times distance. So it will be this area times this distance, to be this area times this distance. So here, when we take moment about y-axis, we will get what? The x centroid distance. So the distance, we'll find the distance of the centroid from this y-axis when we take moment about this y-axis. So it will be this, which is equals to a1 x1 plus a2 x2 over the sum of the areas, which is a1 plus a2. This will be what? What's a1? 20 times what's x1? 1 plus a2 is 28 times x2 is 9 over 20 plus 28. So this is 20 plus 20 plus 28 times 9 over 20 plus 28. This is 5.67 approximately. So the distance of the centroid from the y-axis is what? Is 5.67 centimeter. So this is the distance of the centroid from the y-axis, since we have taken moments about the y-axis. So it will be from this axis. Now, let's find the distance. Let's take the moment. Now, let's take the moment about x-axis. So if we take moment about this x-axis, it will be these areas times the distance here, then this area times the distance here. So it will be, we are going to work with y distance when we are taking moment about x-axis. So it will be what? A1 y1 plus a2 y2 over a1 plus a2. This becomes what? 20 times, what's y1? 5 plus 28 times over what? 20 plus 28. 20 times 5 plus 28 over 20 plus 28. This is 2.67 centimeter. So now that means the center of gravity lies here. It will be 5.67 on this x-axis to be from 0 here to 5.67, maybe to be somewhere here. Then on y is 2.67. So here it will be maybe from here to somewhere here. Maybe the center of gravity lies somewhere here or here. Since it's 2.67, okay, here is 2. Since here is 2, so it will be above 2 here. So since this is 2.67, so the center of gravity will be here, maybe from here, then 5. This is 2, another 2. Okay, so it will be somewhere here. So it will be here. So the center of gravity will be maybe somewhere here at this point. This is where the center of gravity will be located. So we have successfully found the center of gravity somewhere here. So it will be somewhere here. Then the other one is what? It's y, 2.67. Y, that is y on this y-axis. So it will be, so on this y-axis, so it will be somewhere here. So at this point, this is where your center of gravity will be located. So at this point, this is where your center of gravity will be located. So the center of gravity of this shape is somewhere here. So this is how you find the center of gravity of an unequal angle section using the method of moments. I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email written in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share, and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.